Today we're going to be talking about geometric probability. And so what that really is finding probabilities using geometry. All right? So the probability of winning a carnival game depends on the area of a target. Probability that involves geometric measures like area of a target or a length is called geometric probabilities. So if I look at this whole thing right here, the probability of having some point be chosen from B to C, let's call it X, is the length of BC divided by the length of the whole thing, which is AD. And so if those are values, we actually would just set numerical values for BC and AD. So let's look at an example. It says, suppose a point X is chosen at random on J to M. So both of them together, right? What is the probability that X is from K to L? Well, we know from K to L is 7, right? And we know that the length of J to M is 3 plus 7 plus 4, which would be 14. So the probability of picking X between K and L would be 7, because it's just 7, divided by the whole thing, which is 14, or 0.5. Remember, our probabilities are given as decimals, not as percentages or normally as fractions. We write them as decimals, 0.5. Okay, now here's a couple other problems. Let's look at A together. It says, suppose that X is going to be on LM. Well, LM is going to be 4, right over here, LM is 4 out of the 14, which written as a decimal, if you use your calculator, 4 divided by 14 is going to be 0.2857. So it'd be 0.2857. And we're going to get in the habit of using 4 decimal places when we do decimals. Okay, I'd like you to try letter B now. Here's a word problem. It says, the information at the left over here says a Chicago Transit Authority train arrives or departs a station like Addison on the red line every 15 minutes. So it says, assuming you arrive at Addison on the red line at a random time, what's the probability that you will have to wait 5 or more minutes for the train? So right here is 5 minutes, and the train comes every 15. So the amount of time from 5 to 15 is 10 minutes over the whole amount of time that the train comes, which is 15 minutes. And so the probability that you're going to have to wait 5 or more minutes is going to be 10 out of 15, which is going to be 0.6667, or 2/3. Okay? Here's a guided practice problem that you can try in your notes now. Now, we're going to look at probability with areas, okay? So probability ratios with areas are basically just taking the area of one region divided by the area of the whole region. So it says if E is a point randomly selected on A, or in rectangle A, then what are the chances that it's going to land in the circle B? Right over here. Okay, well, it'd be the area of B divided by the area of the whole thing, which is A. Okay? So there's a couple things we have to assume when we do these problems. A, that the object lands within the target area. We're going to assume that happens. And B, that it's equally likely that the object will land anywhere on the region, meaning it's not that, if we're looking at, a circle on the ground, that like the middle wasn't raised up. That would change the probability. We're just assuming it's all the same. All right, so it says for this one, suppose a skydiver must land on a target of 3 concentric circles. If the diameter of the center circle is 2 yards, okay, so I'm actually going to redraw this, okay, and then we have like a yellow, and then we have like blue on the outside, right? Okay, it says the diameter of the first one is 2, and then each one is 1 yard apart. So this would be like another one. So this would be, all right, so that would be 1 more yard. And then that blue would be 1 more yard, right? And so it says if the diameter is 2 yards and the circles are spaced 2 or 1 yard apart, what is the probability that the skydiver will land on the red circle? So we need to first find out or figure out the area of the red circle, okay? And so if we look at that, remember area of circles, okay, circle area, this is important to remember, is pi r squared. So we need to know what the radius is. Well, if the diameter is 2, the radius is going to be 1. So this is going to be pi times 1 squared, which it is actually just 1. So it's just going to be pi. That's the area of the red circle, okay? Now, we're going to divide that by the chance of him landing on the whole thing. So that would actually be the area of the blue circle. So if this radius is 1, and then we have another 1, and then we have another 1, that's a total of 3. So the area of the blue circle is actually pi times 3 squared, which would be 9 pi. Now, if we wanted to figure out what the chances of him landing on the red, it would be 1 pi over the whole thing, which is 9 pi. So our probability is going to be pi over 9 pi, which if we cancel out is just 1 over 9, which we know to be 0.1111. If you didn't know that, you can go to your calculator and actually just type that in. 1 divided by 9, it's 0.1 repeated, right? And so this is our chance of landing in the red circle. So again, not very good chance, but he could do it. Now, here's a couple guided practice problems. What you could do is you could figure out the probability of the skydiver landing in the blue region, which the one thing I want to point out is if you're landing in just this blue region right here, right, you can't assume that that's the area of the whole circle itself. It's just that. So what that means is you take the area of the whole thing, which is 9 pi, and you'd have to subtract it by the area of the yellow circle, the whole yellow circle, which would be pi times, well, if it's 1, 2, it'd be 2 squared, so it'd be minus 4 pi, which would be 5 pi, right? So the blue actually is just 5 pi. And so the chances of landing in the blue region would be 5 pi over 9 pi, which is actually just 5 over 9, or 0.5555, repeated. And so it's only about 56% he's going to land in the blue. You try letter B now. All right. Example 4. It says using angle measure to find probability. Now, the one thing we have to remember is what a circle adds up to. We know that it adds up to 360 degrees, which is helpful because if they give us the angles in here, the way we find our probability is just dividing the angle given by 360. So what's the probability the pointer lands on yellow? Well, yellow is 45% out of, or 45 degrees out of 360 degrees. And so as a decimal, that's going to be 45 divided by 360. That's going to be 0.125. Okay. What's the probability of landing on purple? And this is actually purple. I know it doesn't really look like it, but it is. Okay, and so that's 105 out of 360, right? And so we'll go to our calculator and we'll say 105 divided by 360. That's going to be 0.2917. 0.2917. Okay? And then finally, the last one, it says the probability of the pointer landing on neither red nor blue. So together, red and blue make up 70 plus 50, which is 120 degrees. But we want to say it's everything else. So if I was to subtract 360 from 120, it's 240 degrees is everything else. So we'd say 240 divided by 360 And we go to our calculator. 240 divided by 360 is 0.6667. And so about 2/3 would be that probability. So I want you to try A and B now. All right, if you have any questions going along, let me know. Otherwise, good luck on your next assignment. Hopefully this one is a nice, easy one for you. And let me know if you have anything or you need anything.